Thank you everyone for coming to the session, Quality Assurance Strategies for Manufacturers of Rechargeable Batteries. I have with me Jim, Lars, and Amy. They're going to be our panelists, and I chime in when possible, but I will be moderating today. Let's start with a quick round of introductions. My name is Herminso Gomez. I'm of Charlotte. I actually went to University of North Carolina, Charlotte, right here in this town. So I'm happy to be back. I've been with ZEISS already over 6 years, been in the industry of X-ray quality inspection for a little over 10 years. So my background, additional to physics, is X-ray and quality inspection and metrology. So please go ahead and introduce yourself.
Hello, thank you for coming. My name is Jim Bianca. I have over 30 years of metrology experience, 11 with ZEISS. My current role is an NEV sales leader.
Hello everybody, my name is Lars Virgin. I'm an application engineer at ZEISS. I've been at ZEISS for 10 years. I'm a part of our NEV team as well as our automotive team. I work hands-on with all of our customers to provide application solutions for all of their challenges. I do work with batteries, e-motors, fuel cells, as well as combustion engine components. So pretty much all around automotive experience, and excited to be here today. Thank you.
My name is Amy Ozerchuk. So I'm the CT product sales manager for the Southeast. Been with ZEISS for almost 7 years now, and I'm local to the area. I'm transitioning into a role where I'll be the Southeast business sales manager. So I'll be responsible for sales for optical, tactile, micro, our entire portfolio of metrology solutions. So really happy to be here. Thank you.
Well, thank you for being here, and thank you for being the great energy you have for this. I see you brought
I brought the energy.
Charging battery. All right. So let's kick things out with questions related to the strategy role of quality. So the first question I have for you is, when you think about battery quality control, what's really at stake? Why does it matter so much?
In my opinion, quality control has 4 key points. First is safety. Second is general quality. And when I say general quality, making good batteries, having a good process. Good quality batteries give you longer range and last longer. Third is financial. Just like any component that's manufactured, scrap causes financial defects. And you go to maximize your process and to maximize your profit, you want to lessen the amount of defects you have. Also recalls, you don't want bad parts out in the field, so quality control helps with that. And fourthly, federal regulations. Basically, we're forced. We have to make good batteries. It's controlled by the government, and that includes everything I said: safety, good quality batteries, and financial.
Yeah, I guess from a broader perspective as well, in terms of what's at stake, I think everything's still at stake. I remember when we first started our big initiative at ZEISS back in 2018, 2019. There was a huge headline in the news about Tesla that randomly had a catastrophic failure. It was purely sitting still in a parking garage. And any headline still causes a lot of distress with consumers. So I think quality control is still extremely important, because any failure causes these headlines. And if we want the EV industry to pick up, and needs to get the trust of all consumers as well as manufacturers. So any failure goes against that trust, and we need to make sure batteries are made safely and well, so that we don't see those failures and gains trust of everybody.
Any other opinions? It's very important the points you have made. One thing I wonder is how our overcome the roadblocks that sometimes companies have. As you know, there are limited resources, and they might prefer to put those resources on R&D, on making a profit. Quality, sometimes it seems like it's in the back of their mind. So how we turn that around to make more of a competitive advantage?
Quality is sometimes seen as a necessary evil in all manufacturing, something the owner definitely doesn't want to purchase, but it's a necessity, especially when you want to work with OEMs. The way you benefit from quality is, like I said earlier, making less scrap, making only good parts, not having recalls or failures out in the field. That turns into profit.
Yeah, to back that up, I agree with everything Jim just said. I think a lot of people do view it as a necessary evil. A lot of people still view it as you're doing this check at the end of all of your manufacturing process just to make sure that it passes this final check. And in reality, you can put manufacturing or quality inside manufacturing at nearly every step to make sure that you're making the products well along your entire process, to catch it right away instead of wasting so much effort and money and time on a part that already failed way at the very beginning of the process. And putting those checks inside of your manufacturing process can really be viewed as kind of a weapon for efficiency and profit, because you're not wasting all that time and money and effort.
Yeah, just to add to that, right? So battery is still emerging in the market compared to, say, combustion engines, right? And so if we want battery technology to take off and be embraced in the automotive industry, we really need to stress the safety first, which starts with quality. So I think they go hand in hand. I don't see battery vehicles taking off in the U.S. without winning over the consumers and building trust with them, which starts at quality.
How do you see the different regional focus? And when I'm asking this, are there any regional cultures across different countries like Asia, Europe, or North America in terms of quality control focus for batteries?
Yeah, from what I've seen globally.
Maybe you can share the mic, please.
Yeah. Yes, from what I'm seeing globally, it's kind of all over the map the way they approach quality with the batteries. What we see in Asia, mass production and making batteries as fast as possible is incredibly important. When you are in Europe, you'll see a little bit more stringent standards there. And in the United States, we're kind of on the conservative side also. We're choosing quality over quantity. So it's a little slower for us to get these lines up and running, just because we're trying to make a good battery every single time. So our processes are a little bit slower, only so we can inspect every cell 100%. And that's kind of where we're at right now. And our government's also overseeing this whole thing. So we have federal regulations for batteries here as well, where you won't see that across the world.
Yeah, I'll back up your points as well. I do think certain regions, there's a big focus on speed, especially in China, where it's mass production. In the US, I view it more of a hybrid. I think in the US, we've been so focused on combustion engines for the last 50, 80, 100 years. And this is finally a new point in time where we get to pause and rethink all of our manufacturing processes. I think a lot of the combustion engine companies have kind of developed a formula. So every time they have a new engine come out, it's almost a cookie cutter response of these are the machines we need. They don't bring them at the wheel each time. And now with the batteries, it's finally a chance for everybody to pause, look back at what's worked in the past, but also look to the future and how we can improve a lot of these processes and, gain the trust of consumers.
Yeah, just to add to that, right, so the other thing that's unique about the U.S. market is that, you look at the map, right, we have a lot of distance to cover in the U.S. compared to, say, China and Europe, right, so there's not only is there a race right now in the battery industry to develop and have the most robust and advanced batteries, but also the demand on the vehicle, it's expected that the battery can last longer
That's a great point. We have long distances to travel, and on top of that, the United States likes SUVs. They like the larger cars, which takes larger amount of batteries, which is heavier cars. So we have that additional challenge as well. So I just wanted to add that.
I don't know how many electric pickup trucks there are in Europe, so.
Right.
Amy, let me follow up with you because you, during the introduction, you mentioned you are in charge now of the Southeast. And we are in one of the places of the Southeast right now. So what is the uptake you've seen in terms of manufacturing concentration in this region, and why do you think it's so?
Yeah, we're very fortunate in the Southeast that now we have the battery belt, so the 85 corridor that goes even from where we're at in Charlotte all the way down through Alabama, right? So there's a plethora of battery and automotive companies that are relocating down here, and so it's created this huge opportunity for the Southeast in particular because, historically Detroit, that was the automotive, mecca, right? That's where just all of the cars were produced, that's where all the Intel was, but now the Southeast is coming on the map, right? So there's all these different battery companies they're moving here from around the world, but then also, right, like the Fords of the world, they're building their battery factories down south. So we're very fortunate to, have the Southeast market be growing in this way, but then also now we can concentrate on the knowledge side, the application side, where we invest in our engineers so that they can be centralized and local and closer to the customer, while also working the added advantages of working with multiple different companies at different stages of the supply chain, which before the Southeast never had.
Nice. I see all of you have emphasized some of the key points of why quality control is important in terms of managing risk, safety, reliability. Maybe if we go a little more deep, what are the typical inspection failures that people worry the most? Like what's typically what the manufacturers are looking for when they are inspecting a battery?
Yeah, I guess just to start with the broadest answer possible, and I always like to steal Jim's line. Batteries are a multi-scale challenge. You have challenges from when it is a giant battery pack, a battery tray that's built into the car body. You have battery challenges at the module level, you have battery challenges at the cell level, all the way down to when it's just a fine powder. The inspection challenges that are there for the battery truly start at a nanometer level. That can cause a catastrophic failure from a nanometer level all the way up to when you're talking in feet and meters for an entire car body.
So just to add to that, right, it's important that when we talk about battery inspection that we consider all stages of that process, right, from powder to finish. And so we're very fortunate to have a portfolio that follows that entire process, right? So it's very important for companies to invest in, partners that have solutions from microscopy down to the nanometer level, right, with optical, with tactile, with X-ray, so that you can collect all of that data and follow the battery manufacturing process throughout every single stage, and then report back so you can fine-tune your process.
Nice. So you hit some interesting points there. So it's more of you have to take care of the full ecosystem around batteries, from the raw materials to the finished devices. So it's not just inspecting batteries when they are already done. It's also checking for the materials. How manufacturers that are in the end of already putting batteries into cars manage this full workflow from both, from a commercial point of view, is it through partnerships, and from technological point of view, because you just mentioned the ideal solution for them is to be able to correlate the data all the way from R&D to production. So if you can comment on how can they potentially approach that from your point of view.
So inspection, there is the option to traceability for each cell as you're inspecting it. batch number, lot number, and date of the cell. And that can be traced all the way out into the field. So if there is an error, or if there is a problem out in the field, we can go back to the results and see where the problem started. And you'll find that sometimes the problem usually starts at the nanometer level, like they indicated, using a light microscope, identifying the powders, looking at the powders. The powders need to be pure. The lithium needs to be pure. And the grain size is incredibly important. That all affects the battery and the battery life. So that's what you'll find.
Any other comments? Let me dig a little more into that. So, Lars, for example, you were mentioning some of the main features. What are the typical features that you see for battery inspection right now?
Yeah, right now, I think there's a huge focus on CT. CT is huge in batteries. A lot of the challenges that we see, customers need to make sure that there's not going to be a failure. And a lot of the things that the customers are looking for are built inside the battery. And in the past, the only way for customers to find these problems, diagnose these problems, were to do an entire teardown of the cell after it's been made. You do a teardown of the cell, you're talking about millions and millions of dollars in a teardown facility, hours and hours at a time to dissect a single cell. With CT, these customers can save a lot of time, a lot of money, by simply scanning the final cell, and being able to look throughout the cell itself, look for anode overhang, diagnose the welds to make sure that they have secure welds around the enclosure, around the top prismatic can, as well as to the foils and sides and bus bars. You can look for inclusions for any contaminants that came in from the powder, or not even from the powder, but any step along the process to get from the powder through coating, through folding of the pack, all the way until it's finally welded. So inclusions can happen at any point, and it's still critical to find them if they exist. Weldings are critical. They lead to some of the most failures out there in the cell. Anode overhang is one of the most difficult process to control in itself because it's completely automated. A lot of folds with very, very thin materials, very fragile materials with the separators. Those are often maybe 20 microns thick in itself. So there's oftentimes a lot of issues with the stack, and you see that with the anode overhang, and that can lead to critical failures as well.
Yeah, thank you. So what I get from it is not just checking or inspecting the battery, it's everything that goes around a functioning battery, the electronics, the bus bar, potentially battery trays, and all of that. You did especially mention CT, which is computer tomography. I'm going to take advantage of you being working with CT for a long time already. Why is X-ray CT so special?
So it's really hot in the battery market right now because, going back to Lars's point, CT and X-ray is the only way that you can non-destructively inspect these batteries without teardown, right? So teardown is very expensive, it's very time consuming, and so there's a lot of value add in being able to take a cell, put it into, the CT scanner, it's like a magic button, right? And then you can see inside of the battery in its current state. And so that's really important, not just for inline inspection, but then also failure analysis, right? So where if you were to take the battery and try to inspect it without CT, right, then you have to dissect it, which is also very dangerous, right? Versus, not only when you put it in the CT scanner, you get that data instantly and you can do your quality checks, but then now also you have a digital twin of that part. So let's fast forward, and now that cell is out into the field, and it's been used, and you archive that digital twin, that data set, and then come and find out maybe there's a potential failure of that cell. Well, you can go back to that digital twin and actually dissect it and analyze it and check different areas that might not have been on your quality map in the first place, right? And so that's, in my opinion, the biggest value add of CT, right? So not only does it save money because you're not doing tear down, right? And then you get all of the added bonuses of being able to see inside of it, but now you have the traceability and for that digital twin to then go back 6 months, a year down the road, and then be able to inspect it and analyze it for something that
So what I take from it is one of the main advantages from X-ray is non-destructive. So, and we all probably know and see videos what happens when you try to open a battery. It creates a fire, right? And if the electrodes touch each other, it's pretty dangerous. So I get that. Now, can CT be used inline?
Yeah, so we're getting there, right? So a couple of years ago, no, that wasn't even on the table, right? But we've been listening to the market, been listening to our customers, and because the well checks specifically are so critical to safety, there's this huge demand now for inline CT, which we're finally there, right? So we do have solutions. We are in the market with, say, completely automated CT systems, right? When it comes to the software and defect detection, material handling, sorting, loading, unloading, right? We're finally at that stage. And we've only gotten there from working with our customers and getting feedback, and them kind of leading us, weld inspection in particular is a very, very high concern, and that was one of our first applications that we led with for this inline solution for CT. So it's very exciting times. I look forward to that pace continuing.
Yeah, I'm still curious to see how much, if it is really a 100% inline inspection, because plants are making up to 1 million cells per day. So I imagine the speed of inspection would be really fast. So, but let me change a little bit, going back to back in the process, because we're concentrating now in finished batteries and maybe checking not only quality control, but failure analysis. But going back to the initial stages, when you check the powders, for example, Jim had mentioned that the resolution we need there is in the order of nanometers. Is CT or computed tomography still a good solution for that, or you need some other technologies?
So a light microscope is typically what you would use for the powders, and it's very common. It's actually required, and that would measure the grain size and the purity of the raw materials. And again, you have to start with good materials before you even begin to make a good battery. So it's essential to start with measuring the raw materials before you start assembling them.
Just to add to that on the CT side, right? So a lot of the CT solutions that I've mentioned so far are at the same micro level, right? So they're at maybe 10 microns, 50 microns of resolution, right? We are fortunate to have a technology that's the nano CT, it's the Versa. No, it's not a production solution to any stretch of the imagination. These scans are several hours long, right? But we actually have the ability now to do a full, at the nanometer level resolution CT scan, which is most helpful in that material stage.
Yes, nano CT is a good technology. Still, I don't think nano CT can embed the resolutions of an electron microscope or an SEM, right? So at some point you will have to go to the SEM level. The disadvantage there is you have to actually prepare the sample, and you have to put a portion of the sample to put inside. Okay, let me continue now toward what's the role of AI and automation in all of this process. You've mentioned several technologies. If we get to make them faster, then we're collecting a lot of data. And what do we do with that data? Is AI going to help? What's the role of AI on all of this?
Yeah, so sorry to keep going back to CT, but obviously I'm biased, right? But what AI has allowed us to do on the CT side is we've collected tens of thousands of hundreds of thousands of X-ray images that we can then feed into this machine learning model so that we can detect defects sooner, faster, more reliably, more accurately. I'll give you an example of that, right? So if you look at it as an X-ray image, right, there's 65,000 different possible grayscale values, right? Those different shades of gray that you you see on an X-ray image. The human eye is only capable of maybe distinguishing a dozen different grayscale values, right? But what AI has allowed us to do is now we put all of these images into a model. The computer is much, much more sensitive and reliable and consistent and accurate at detecting the slightest different variations in those grayscale values. So now we can detect failures sooner, right? Before they get larger, and now when I can pick it up, right? They can pick up those shading differences. It might be too late, right? But now if we rely on AI and machine learning, we can actually detect these failures earlier and more reliably with the thousands and thousands of images that we've collected over time.
Yeah, just on a even broader level, when you talk about especially CT specifically, and thoughts of doing inline inspection, or even just in the lab, the sheer number of batteries that need to be inspected on a daily basis, whether it is lab or inline, that it requires fast cycle times. I've been in the industry long enough to have seen cycle times in CT span hours for simple scans. Over the past 10 years, it's been fascinating to watch the sheer speed of CT drop from these hour scans to the same parts being scanned within seconds. Now that you've scanned a part within seconds, you still have gigabytes worth of data that somehow has to get analyzed. Just because it was scanned doesn't mean that there's a magic button that's going to go and say this is a good part or a bad part. We have a bunch of scan data that needs to be constructed and evaluated. In the past, it's always been done by an operator or an engineer, a trained CT user. And just an individual analysis with a user is going to take time. So it's important that if we're trying to keep up with these fast cycle times, to eliminate that manual process and have it be evaluated by a computer somehow.
There's no way we can hit the throughput demand without using AI.
Yeah, and the more data you have, the more confident results you have through AI. And the more confident results you have, maybe you have less need for 100% inspection. You can start using sampling instead of 100%. And that's what AI gives you with all of that data. More confident, consistent data.
Yeah. Do you think AI can help us predict some trends also by checking all of those different types of data and see, okay, this is potentially going to fail after certain cycles of charging or discharging?
Yeah, absolutely. Again, more confident data will enable you to identify trends way before it becomes a problem. You can make real-time adjustments to the machine. So yeah, absolutely. The more data, there's so many benefits to that.
Yeah.
And kind of deviating away from just the pure battery side of it as well. Using it in castings for car body, looking at the battery tray. This sort of data can also be used for how quickly things are cooling, what temperature is best used for the castings, to eliminate porosity within those castings, identify porosity before machining even happens. There's a lot of other uses for this technology in the automotive space as well than just analyzing batteries.
Yeah, thank you. That reminds me, I wanted to go back to you and take us away from the X-ray CT. We've been talking a lot about that. But what are the type of technologies you use or people use to inspect casting? What is really important there? And I suppose we're talking about the battery trays, right?
Yeah.
Where you put the battery.
Yeah, so there's a number of technologies that can be used. CT is very popular, but when you move to the scale that some of these parts are now being produced at, like the giga casting, it's a very popular term now, where you're talking about putting a battery tray completely integrated in the car body of the automobile. Those parts are huge. A lot of those cannot use certain CT systems and require other specialty pieces of equipment like 3D optical scanning. Large CMMs also exist with laser scanners that can create 3D point clouds of these parts to show if there's any warping, any flexibility within those parts, make very clear CAD to nominal deviations to make it easily understandable data, to make it more trustworthy, more reliant, more traceable, and just easy to understand for everybody.
So when you talk about like checking for some of the tolerances. The familiar term for the metrology people in the room is GD&T. So we're moving away from inspecting the inside, which in a casting would be like porosity or so. What do you inspect with dimensional tolerancing? What do you inspect in a casting, and why is so important in a battery tray? Let's say.
Yeah, I mean, the most common call out would be profiles. But I mean, when you talk about the battery tray itself, it has to hold all of these battery modules. It's a lot of weight. It has to be able to protect these battery modules from external forces like weather, any debris on the road, and it has to be able to hold this structurally and sound, so there's no warping no matter the weather. So flatness is very important. Diameters are always important. Position, all the key GD&Ts are very crucial in those scenarios.
Are the quality inspection or quality control requirements different or for different type of battery form factors? So we know there is cylindrical cells. The battery tray is composed of a bunch of batteries, right? Some of them are cylindrical batteries, others are more of a pouch battery, which is like a thin layer, and some others are prismatic battery, which is more like a brick. So how does the quality control change? Or does it change at all? Or is more or less the same?
So to me, it's more or less the same. I mean, there's certain different checks that we look at. If we're working with the pouch cell, we are more concerned with looking at swelling. That's something that typically is a lot harder to see in prismatic cans with the hard side. That hard side typically protects from any sort of puncture or swelling. But with the pouch cell, it's much more susceptible to that, so it is a concern. And again, if you're working with pouch cells, there's significantly more of those thin cells being packed together, so it's important that they're all made to an optimal size, because any swelling or thinness involved is going to create errors within like the stack up of multiple of these cells.
Any other opinions?
Well, again, a lot of the products that we're talking about are fully customizable and can be changed depending on the application. So if there is a new requirement for a certain kind of battery, it's not very difficult to go ahead and change the approach for the measurement system.
Okay, I'm going to move now into trying to see what is your take in the future outlook. Like, if you were to look ahead in the next 10, 20 years, where are we moving in terms of scaling? Let's say, what's your perception? What's the future of battery quality control in the next 10 to 30 years? Is it about getting better measurement systems, smarter measurement type of systems, like it's about physics, engineering, or is it more about smarter interpretation, better software, using tools like AI?
In the future, in my opinion, just like any component that's new, you want to measure 100% inspection. You want to get your process down and understand the process challenges. I feel in the future we're going to nail the battery production. I feel we're going to be more confident, we're going to understand the process a little bit more, and even make it more efficient. Then you don't need to measure 100%. You can have your processes as fast as you want and measure samples as you go. Still use high quality equipment to measure it, lots of data for highly confident predictive analysis, but still I don't think 100% inspection is going to be necessary. Again, just like other components that we've seen throughout history, we've ended up perfecting processes and then only taking samples to control it.
Yeah, I agree, Jim. I think the easiest way to sum it up is in the next 10, 20 years, it's all about building trust. EVs, any new technology that comes to the market is never going to succeed without consumer trust. And to win consumer trust, we have to be making good parts that are not going to be having failures. And like Jim said, with trust comes reducing the frequency of inspection, applying learning lessons from different manufacturing processes, and getting to the point that we see in the combustion engine industry, where it's almost like a formula at this point of, we have a new engine, we've changed these certain things, here's how we apply the lessons from the last one, here are the machines that we need. It's about getting to that point that no matter what format of cell we decide to put in the car, this is the formula that we're going to use, and it's tried and true, and we've been doing it for years.
No, the consistent theme here is AI and automation, right? So, and you could say that for any industry, right, moving forward. So, that's where, we're very confident in our solutions, right, and having the entire portfolio. We're very privileged in that regard to take data from, the micro level all the way up to the fully assembled state. So at this point, consider this like the knowledge gain stage, right? And then now we can optimize those AI models and then deploy them to where now it maybe is just a sample inspection. We don't even need 100% inspection because we refine that process. So consider us right now in the industry, maybe the data collection stage, which we have plenty of.
There are kind of a couple of terms that we have used very consistently here: quality control. I also hear about failure analysis. Maybe if you can do a clarification how those two differentiate. Is there a difference? Would you use the same tools for failure analysis as for quality control? Which one is more important to attend to? So if you can elaborate on those.
So the difference between quality control and failure analysis, I think they both use the same tools. Failure analysis is kind of, the way I view it is as Jim's definition of the necessary evil. You have, overlooked this thing. We always thought inspection was this, we'll do it at the end, we'll check, make sure that we get a green smiley face and we're good to go. But what happens if something gets past that and fails? All of a sudden, inspection becomes critical. It's a full five fire that we need to figure out the solution, what went wrong, how can we fix it, how can we stop this fire from happening. Quality control is the opposite side. It's we've been paying attention. We know we don't want anything bad to happen. We want to learn along every step of the way that this component, this battery has been made properly, and catch any failures or any errors in the process before they get to the next step, before they get to a final product, especially. And it's applying the same tools that we would use for failure analysis significantly earlier to prevent anything from happening and have that full traceability along the way.
Yeah, just not to, again, go back to CT, again, bias, but that digital twin that I talked about, right? So how would you categorize that, right? Because, if you use CT in line, now you have that data, you're archiving that digital twin, battery comes back as a potential failure. Well, you're relying on that same data set now, just in a different capacity, right? So you're taking the same tool, the same technology, but you're just inspecting it under a different scenario. But it's the exact same technology, you're using the same data at the end of the day. So just applying different principles.
Okay, so I want to give the public a little bit of time for questions, so let me go to final thoughts, but I hear a lot today about AI, the role of AI, predictability, trying to control the process early on, quality control, rather than failure analysis, though you can use similar measurement systems for those. So is there anything we have missed in this discussion that you consider important?
In regards to AI?
In regards to the full discussion around quality assurance strategies for rechargeable batteries. Is there anything else you want to add?
No, just maybe some final thoughts. I mean, the goal is to make the best possible battery consistently. And that means having a process that's under control. And really, the only way to do that is inline inspection, and you have to use some sort of X-ray or CT. You can't open up every single battery as it's going down the line. You have to use a non-destructive procedure. And do not want any batteries leaving the facility that can cause catastrophic failure. So that has to be identified before it leaves the facility. And so that is the bottom line for all of this, is process control for good, consistent batteries and making sure one of those outliers doesn't leave your facility that can cause problems out in the road.
Mine's funny, 'cause mine's kind of, I agree with everything you just said. I think inline is incredibly important. I think the one thing that we kind of overlooked was at-line systems still being critical. Inline systems are very important to make sure that you're getting your 100% inspection, but oftentimes they can take certain shortcuts to get very quick data and not thorough data. So in my opinion, it's important to not overlook those at-line systems, those lab systems that can give you the full picture of what's going on, that maybe you're getting the shortcut from the inline system, but also give you the flexibility and the offline time to fully troubleshoot and figure out what's going wrong in your process, that you can't pause your line while it's going. But if you have a system outline your line that can help you troubleshoot that, you can, I think, get more thorough answers.
Now, just my closing thoughts is that I'm very excited about the direction that the industry is going, right? The answers to these questions would have been completely different even a couple years ago, right? So all of us are very fortunate that we've seen the evolution of battery in the US really transform, and it'll continue at that pace, right? And so we're very fortunate to have an eye and a hands-on approach with the market, with our customers, so that we get that data instantly and that we can adjust actually our solutions based on the market demands. And if we just keep up with this pace that we've seen over the last couple of years, next year's battery show answers will probably be very different.
Okay, I do have one last fun question for each of you. What is draining your energy these days, and what is rechargeable?
Okay. Email replies that are constant, meetings about meetings. Okay, that really. But to charge me up is a good night's sleep. The older I get, I mean, I have a health band on. We're just talking about health bands. This health band can probably answer that question more than I can. You know, what recharges me? But so far, it seems to be a lot more sleep does it for me.
Do you have a battery there?
And there's a battery in there, yeah. And it's working. It works for like 7 days. So.
I guess what's charging me up is I get to get out of Detroit for a few days, come down here to Charlotte. Lovely town, excited to be here. What's draining my battery? I'll go with the Detroit Pistons, being down 0-1 in their series, and hopefully they turn that around tonight.
I think we all drove here likely today and likely went through some sort of construction. And so as someone who lives in the area, what is draining me is the construction, right? And trying to navigate the new skyscraper that's coming up this week and then the next one right next door. But on the flip side of that, the growth is charging me, right? So I've been in Charlotte for about 8 years now, and that's nothing compared to everyone else that has been here maybe 20, 30 years. That, you know, they say it's changing rapidly, but even in my short time, I'm very fueled by the growth that's happening in the Southeast. I'm very excited for it.
All right, thank you, and let's open the floor for questions from the public. If I can have someone help me passing the mic.
I can yell.
Yeah, if you can help me passing the mic.
Great. Thank you very much. Great presentations. How many nines can we get to?
How many what?
How many nines can we get to? How accurate can we make the manufacturing process? I think when we talk about how accurate it is today, again, I'm not an engineer. I always hear about how many nines of accuracy you have to get to today and what battery plants can do today in the United States, what they're doing in China at a higher level. Of all of what you described about the revolution of AI and these new inspection technologies, it seems like the sky is almost
goal is 0 defects. That's the goal, is making sure processes are under control. We utilize AI for predictive failures, predictive analysis, and having 0 defects. So in terms of nines, I don't know, we deal in microns, that's a 0.001 of a millimeter. We deal with actually submicrons. So you'll see a lot of that in our process and our measurements. Again, I'm just going to say 0 defects is the goal. That's what we're striving for.
Yeah, and actually, follow up really quick. As an application engineer, I'm often on machines. I agree. We're dealing with fractions of microns all the time. And I think the common thing that I see is everything is extremely highly over-engineered, especially when it comes down to that print. People like to put super tight tolerances on it, almost because they say our CMM can hold that, so why not put it on our print? But that actually just makes everybody's life even harder, because now you have to make sure your whole process matches up to that, just because your CMM can do it. So oftentimes I feel like we scope out machines for requirements that don't need the 4th decimal, 5th decimal, rarely the 3rd decimal. So, yeah.
I guess the answer is however accurate the market needs us to be, that's what we're.
Well, I'll give you the obvious example that we have, let's say, and I'm pulling it out of the air, 1 in a billion rate of defects in lithium battery cells today, which sounds really impressive until you consider that we've put 4 billion battery cells on airplanes every year. Suddenly that level of 9 of perfection doesn't sound quite so good. And there's a constant, our goal has always been 0 defects. That hasn't changed from today, and it will be the same 10 years from now, but the rate of defect, or at least the lack of defect, that we hope is really going to be seriously, we'll make progress on that. The technology you described is exactly the type of technology we're going to be relying on to do that, and I'm just interested in whether or not anyone in ZEISS has really thought in on a larger level, what does that actually mean in terms of the rate of defects of lithium batteries overall? The public's terrified of lithium batteries, and maybe for somewhat good reason. I mean, 1 in a billion, if you're flying 4 billion batteries, makes you think twice when you get on an airplane. What if it was suddenly 1 in 10 billion, 1 in 100 billion? It would be a different discussion we'd be having with the public and with our customers. So again, just throwing that out as an observation as much as a question.
Yeah, and I think it's a fairly good point, especially with lithium-ion batteries and the risk that lithium-ion batteries bring. That's why in the battery ecosystem, there's also a lot of research on solid-state batteries. They still need further development, but it's a promising technology that would be less risky as opposed to lithium. The risk of potential failures from a lithium-ion battery. But anyway, let's move to someone else question.
Hello. Thank you for the talk. I am Abhi. So I would like to ask, how are you going to implement your equipments in the process of your customer? Like, do they come to you first telling that they have a certain defect, and then you come up with a solution? Because right now, more and more solutions are being used, of course, inline or things like that. And let us say someone gives 2 solutions for the same problem, for the same quality inspection. How do a customer decide?
So I will say we're very fortunate in that, because, ZEISS is such an established brand in that market, right, that we have relationships in place with very strategic partners where we get this feedback instantly, right? We have these relationships that have been going on for years and years. So we are fortunate in that we get the feedback from our customers about where the market is heading, where they need us to go, right? And we work hand in hand with them on that, right? So that our roadmap is aligned with what the market demands. I think, is that more or less what you were?
Yes, but I was asking more in the, how do we decide which equipment is best for a certain quality inspection?
So I've actually seen a couple different things working with different customers. Frequently, if a customer like yourself came to ZEISS saying, I'm measuring this battery, what's the best way with all these different technologies? We always view ZEISS as an application solution supplier. We know we have all sorts of different pieces of equipment. Can often be confusing to someone that's new to the field. We always sit down and explain the benefits and cons of each one, and we figure out what solution works best for what you're looking for. When it comes to batteries, I've also seen kind of, I don't want to say the opposite, but totally different approach of customers that we probably have past relationships with coming back to us from combustion engines now making batteries, saying, we're going to be making these batteries and they're going to be making them quick, and we have a year to figure out what we're doing. What do we need? And we almost have to guide them through the process as well. So we kind of see both ends there.
It's also nice because we are working with so many different partners. We see different approaches maybe to the same challenge, right? So we could say, okay, without disclosing, obviously proprietary information, we could say, well, one approach would be, say, optical. One approach would also be sample inspection with CT, right? And then we present all of the different solutions and inspection mediums, and then we really empower the customer to make their own decision, right? And let the application drive the solution, with at the same time presenting them with all the data and potential options.
Also, companies like ours, we can't sit back just with the products that we have. We're constantly developing. We have an R&D department that's constantly creating custom machines for custom applications. And that's for speed, it's for accuracy, things like that. We have new products coming out all the time, specifically for NEV. Not just battery, the entire vehicle, because they have unique challenges all over the vehicle. So we've already developed products specifically for that, and we've done that with batteries as well.
Yeah. You stole my thought, but I will compliment it saying that as any type of business, of course, any battery quality control provider, they need to turn whatever they make into a profit. And of course, the ideal situation is that the battery manufacturer acquire systems that you have ready available for them. Is the solution. But if that battery provider doesn't have it, then it becomes a conversation because there are R&D departments, and the question is the relationship is very important. So first, that the battery manufacturer trusts this battery quality control provider as a reliable partner. Like it actually can provide a solution. The trust is the first thing to establish a partnership. The second then is I say at ZEISS, but this is typically in any R&D department of a big company, is they need to start evaluating the feasibility of what the manufacturer is asking in terms of the solution, and then evaluate the market. So is this battery manufacturer looking for a one solution, just one system, or for several systems? It is going to potentially be beneficial not only for that specific manufacturer, but for the full industry. And when someone that is in R&D and also taking care of evaluating the investment in the next 5 to 10 years, which is product management and all of that, then needs to pay more attention and see, okay, this is an interesting case. We are going to invest in this area. And there are other factors that play a role, which is the geopolitical situation, the economical situation. Is this an economy worth investing? Once all of those things are checked, then people generally move forward, and it can be mutual partnership with the battery manufacturer invest money, or it can be just a one-side investment with a compromise that once the solution is out, this battery manufacturer is going to have the privilege to get those systems first, or at least for the 6 months. First, it's 6 months or 1 year.
Hi, great talk. My question is is, given the power and utility of CT data for the internals of a battery, do you anticipate it being a requirement for certain types of certification, or is it going to be kind of standardized? And is that going to be based on specific defects, specific scan types?
We got you.
Or is it going to be based on certain industries?
Yeah, so at this stage, because I think we're at the federal level, maybe that's moving a little bit slower than maybe the market demands for especially considering safety, right? If it is not formally required and mandated, say at the federal level, I think naturally, because CT and X-ray is the only medium that will give you that level of data, I think naturally the market will drive towards that solution as a default, because there truly is no other way to get that level of visibility in that output without X-ray or CT, right? So, if not formally, naturally, the application will drive the market that way. And that's what we're seeing, is, at least the partners that we work with, and they have some sort of X-ray technology in-house. If not 3D CT, right, then maybe 2D X-ray at a bare minimum.
And I can give you a specific example of market-driven solutions from what just people are asking for. And one of them is the overhang inspection. It's very typical right now. It didn't exist as a request in the previous 5 years. It just came down. Recently, more people are asking, I want to inspect the overhang, which is basically the alignment of the electrodes. And then quality assurance provider then rushed out to create software and systems that do this automatically with AI. Because previous in the past, people were doing it still manually, and I suspect some people still do it manually. But it's not only from ZEISS perspective, which we develop a solution for overhang, but you see all the providers. It's just the classical example of a need that is pulled from the market, and everybody is now chasing solutions in that regard. There are other requirements like that out there. I would say, but it makes unique a company like the one we work for is we worry about the correlation. So we correlate data from like microscopes to electron microscopes, X-ray, CT, CMS, and that's seemed beneficial for a lot of the manufacturers, because you can make those systems talk to each other, or at least the engineers that drive different systems talk to each other easily, as opposed to how systems from different providers, and now you're speaking a different language, a different software. So if you can correlate, especially the process, as some of my panelists mentioned today, going all the way from the nanoscale to the millimeter or centimeter scale, that would be great.
I just want to add to that, because you brought up a good point about overhang, right? So, what the feedback we got from the market is that a lot of the failures that were occurring in these batteries actually started as a result of failure in the weld, right? So that's what made overhang inspection so important, is because battery manufacturers are able to determine if there's a failure around that weld, with the overhang measurement, then it's likely there'll be a catastrophic failure of that battery in the field, right? So then now we react and we rush and we develop these solutions that's particular to the weld inspection, which is overhang.
Yeah, I think the short answer is whether or not standardized or not. If you're not CTing your batteries now, you're probably one failure away from CTing your batteries.
Like I'm sure Samsung wishes they could go back in time and CT all their stuff. So.
Yeah, exactly.
Any other last question that you might have? I think we're close to running time here.
Given the scale of battery technology, the small scale of battery technology, you consider these tests to be non-destructive. How spike growth versus to damage or erase that growth?
I can answer that with the electronics components made in the battery. I haven't seen much of an issue, but I'll give you specific examples of electronics, which is a classical example of X-ray inspection, either 2D or 3D. If you X-ray an electronic component over time, depending on the energy level or exposure time, you might affect some of the components, especially memory devices. It's basically a transition on the electronic level, so in the atomic components of those materials that are in there. I used to work in the lab, and I have one of my friends put off his smartphone and put it into a CT scanner for fun. And the images are great. And it didn't fail. The smartphone kept working for the week. He was excited to continue doing the same thing, so he could put in his own smartphone in the scanner for a second week. After the second week, it failed. It started working. So yes, you might have to be careful, especially with electronic components. With batteries, I haven't seen much of an issue because they are not like special materials that make electronic transitions that are important for the function. It's more about the lithium and the separator and the electrode. We have the advantage of X-ray attenuating with transmission through the part. But it's an interesting question. I don't know if we go all the way to gigabits, we use kbs right now. If we go higher than 1,000 kbs, something may happen. I haven't heard anything, but I try to find out the scientific community if they report something.
The kV for battery inspection is usually between 1 to 200. So it's, we have CT scanners that go to 450, right? At 450 up to 1,000, yeah, it would be more skeptical of damage, right? We're to penetrate the cells are between 100 and 200, which is not massive.
All right. Well, thank you, Jim, Lars, and Amy, for coming with me to this panel. We have enjoyed the discussion. I hope it was helpful. Thank you for your questions. Let's thank our panelists.